So welcome to the video lecture series on theory of computation. In today's video lecture, we'll be learning about how to convert an epsilon closure related problems. So you are seeing that the problem is given in a tabular form, and four types of question has been asked as far as this problem is concerned. So you are supposed to compute the epsilon closure of each state, and you are supposed to identify the list of possible strings which is at most of length 3 or less, and you have to convert the automation to DFA. So you are supposed to convert to DFA, and finally you should give up a string and verify whether it is getting accepted or not. So that is the fourth parameter. So first step what you have to do is, when the problem is given like this, just try to draw the diagram, related diagram. So P, Q and R, there are three states here. So P, Q and R. And R is going to be the final state, so I put double round here. And P is going to be the initial state. Yeah, it should be the initial state here. Okay. So when epsilon is applied in P, it goes to R. So when epsilon is applied, it goes to R here. And when 0 is applied, it goes to Q. So when 0 is applied, it goes to Q, and when 1 is applied, it goes to P and it goes to R. Okay, when 1 is applied. So P, when 1 is applied, it goes to P as well as it goes to R. Okay, so now I come to the second transition. In Q state, you don't have transition for epsilon, and for 0, it goes to P. In Q, when you apply 0, so it goes to P. Okay, and you don't have any transition for epsilon here. One transition does not exist for Q, and the important thing is, when you apply for R, when epsilon is applied for R, it actually goes for the state called as P and Q. So I just put epsilon here and epsilon here. Okay, so it goes to P and Q. And in R, when 0 is applied, it comes to R itself. So 0, it comes to R itself, and when 1 is applied, it goes to P. So P transition already exists when 1 is applied. Okay, so this is the diagram. Now we are supposed to find the epsilon closure for each state. So we have three states here. We will find the epsilon closure for all the states. So now I am going to find the epsilon closure. So epsilon closure for P. So what is epsilon closure for P? So wherever epsilon goes, then that is called as the epsilon closure for P. Okay. So when you just take a P, the first answer is epsilon closure for P is P itself. And when epsilon is applied, it goes to R. And in turn, when epsilon is applied in R, it goes to Q also. And again, when epsilon is applied, it goes to P. So again, P is already included. So P is included, it goes to R, R has to be included. From R, actually you are going to Q, Q has to be included. Okay, so P, Q and R. So three states possibilities. So repetition is not permitted here. Even though when you find the epsilon closure for a particular state, if it appears 2 times, only 1 time the state has to be included. Now epsilon closure for P has been identified. Now you have to go to epsilon closure for Q. So epsilon closure for Q. So what is epsilon closure for Q? When you take up Q, Q actually no epsilon has been applied. So you are going to get Q itself. So epsilon closure for Q is actually Q itself. Okay. Now I go to the third one called as epsilon closure for R. So epsilon closure for R is equal to, so R actually goes to Q as well as it goes to P. So again you are going to get P, Q and R. Okay. So that's about the first subdivision, and I want to find the list of all possible strings of length 3 or less accepted by automation. Okay, so what is meant by acceptance? When a particular string is particular input is applied, if it is able to reach the final state, then we can say that is accepted. But the length here should be 3 or less. Okay, that means 0, 1, 2 and 3. Okay, so up to 3 length you are supposed to identify. So what is the language which is accepted here? So the language which is accepted is, I can say when epsilon is applied, it goes to the state called as R. So epsilon has to be included. And when 1 is applied, okay, when 1 is applied, it goes to R here. Okay, so we will and when 1 is applied, it goes to R. Now see here. So first the language accepted is language accepted. So language accepted L equal to, okay, L equal to, so what happens when epsilon is applied, it goes to R, so epsilon is getting accepted because it is of length 0. And when 1 is applied, it again goes to R, so 1 is also accepted. Okay, this is of length 1. And you see the other kind of input. So when I actually apply 1 in P, okay, 1 in P, one time P can be generated, and if I again apply another one, it goes to R here. So 1, 1 is getting accepted. Okay, and if I see apply 1 in P, okay, and if 0 is applied, it goes to Q. Again, if 0 is applied, it goes to P here. Okay, now what happens is, if I take this one, it comes to P itself. Now if I apply 0, it goes to Q, and it goes to from Q, if we apply 0, it goes to P. So 0, 0. Again, if I apply 1, it goes to R here. Okay, so now the other possibility is 0, 0, 1. It actually it goes to the state called as R here. Okay, and if 0 is applied in P, it goes to Q, and again from Q, if you apply 0, it goes to P here, and in this case 0, 0, and if I apply epsilon also, it goes to R here. So okay, so this is the language which is getting accepted. Okay, and if 1 is getting generated, and if 0 is applied, it goes to Q, again 0 is applied, now it becomes 1, 0, 0, and when epsilon is applied, it goes to R. So even 1, 0, 0 is getting accepted. Okay, so these are the language which is actually getting accepted by this specific NFA. Okay, now we will go to the next one, convert the automation to DFA. So you know how to convert the automation to DFA. Since epsilon is present over here, you are supposed to identify the epsilon closure, and then you are supposed to do that. Okay, so now what is the first point here? When you want to, when epsilon is existing, you are supposed to go ahead and convert to DFA. That means you are going to apply the technique called as NFA with epsilon to DFA. So how to do this? So find the first step. You are supposed to find the epsilon closure for the initial state. And what is the initial state here? P is called as initial state. So epsilon closure. So epsilon closure for P. Okay, P is going to be the initial state. And what is the epsilon closure for P? It is actually P, Q and R. So name this state as A here. Okay. Now what do you have to do? You are supposed to apply all the inputs except epsilon in A here. Okay. So now I am going to apply delta dash of A comma. So two inputs are possible here. 0 is one input and another input is 1. Okay. So epsilon is not considered in this case. Now if in 0, so A is actually, it can be abbreviated as delta of So delta is actually called as epsilon closure. It can be abbreviated as delta dash, can be abbreviated as epsilon closure. So delta of, then what is A? A is actually is equivalent to P, Q and R, and I apply 0 here. Okay, so it can be abbreviated as when 0 is applied in P, it goes to Q, and when Q, if we apply 0, it goes to P here. And now see here, so epsilon closure delta of P comma 0 union delta of Q comma 0 union delta of R comma 0. Okay, when P comma 0, if P comma 0 is applied, it goes to Q itself. Okay, so you just use epsilon closure P comma 0, it goes to Q, so Q union, and when Q comma 0, it goes to P union, and when 0 is applied in R, it comes to R itself. Okay, so R. So now you are supposed to identify the epsilon closure for P, Q and R. So obviously you will be getting only 3 states are possible here, P, Q and R. You are going to get the same answer here. So epsilon closure of P, Q, R, putting together, that means epsilon closure of Q, epsilon union epsilon closure of P, and union of epsilon closure of R. So only 3 states actually existing, so not more than 3 states actually exist in this diagram. So obviously the answer is going to be P, Q and R. Okay, so P, Q, R is actually giving the answer called as A here. Okay, because it is not a new state, which is already generator state here. Now we are going to apply delta dash of A comma 1. So epsilon closure delta of P comma Q comma R, and I apply 1 here. When 1 is applied, so it can be done as epsilon closure of delta of P comma 1 union delta of Q comma 1 union delta of R comma 1. Okay, so when 1 is applied in P, it comes to P itself. So it comes to P itself union. When 1 is applied in Q, actually no possibility is there for 1 in Q, so just make it as pi. And when 1 is applied in R, it goes to again P here. Okay, so it goes to P here, so union P. So P union P, actually it will be considered as 1 state here because it is a repetition. So epsilon closure of P. So epsilon closure of P. Okay, and so when you find epsilon closure of P, the answer is the same answer called as P, Q and R. Okay, so P, Q and R, you are getting the same state called as A here. Okay, P, Q, R has been named as A, it's not new state. So what happens is, when I apply epsilon closure of P, I identified a new state called as A. When I apply 0 and 1 on the respective new states, no new state is getting generated here. Okay, so we can stop here. So we are supposed to convert into an equivalent diagram here. So how to convert this into an equivalent diagram? Okay. So this is actually called as a DFA. So epsilon closure of P1, it comes to P itself. Epsilon closure of Q, it's again okay, P. Okay, and epsilon closure of R is actually comes to P here. Okay, that's it. If you take up this diagram, you can draw a table here. So how to draw the table? Just name it as A here, a Dfa table A, and inputs are 0, 1. So I actually don't have any new states here. So when 0 is applied, it comes to A itself. When 1 is applied, it comes to A itself. Okay, and which is called as a final state. The final state is actually in this case actually A itself, because the original state R actually exists in A. So this A is going to be the initial state as well as final state. You will have a very straightforward diagram here. So A, and in A actually this is going to be also a final state. So when 0 and 1 is applied, you will have coming to A itself. Okay. So now what happens? This zeros and ones can be repeated any number of times. So that's it, the diagram here. Okay. So 0, 0, any number of times, and 1 can be repeated any number of times, and it can go to. So this is the actual Dfa diagram. It's very simple. Now I will go to the last problem here. The problem is you have to identify the delta dash Q0, 1, 1. If you apply this input, what happens? So delta dash, I think it is Q0. So actually it should not be Q0, it should be P here. It should be P. So just make a change here, it's P here. So P. Now if I apply P and if I apply the state called as 0, 1, 1, 0. Okay, so what's the problem here? So now if 0 P, when 0 is applied on P, it goes to Q, isn't it? So just delta off, it goes to Q, and what is remaining? I am getting 1, 1, 0 is remaining here. Okay, now when 1 is applied in Q, okay, no possibilities here. So actually it is going to be the dead state here. You stand in the same position. Okay. So no possibilities. So that's it. So Q1 cannot be applied in Q. Okay. So you stand in the same position. So this string is not going to get accepted here. So that is the point here. Okay. So that is the idea behind this. So thanks for watching the video. Have a good day.